Okay, hi guys, this is the video on the list of projects that you can do for which we have the source code and supporting materials, and they are pretty easy to implement. Before I begin, a couple of the projects here might seem a little difficult, but with some background knowledge for which we will be providing you with the materials, you really won't have a problem implementing any of these. These are the list of projects: audio signal processing, color tracking, DNA image cryptography, echo cancellation, k-means image compression, neural network, simple image cryptography. For the first video, we thought we'll keep it short and sweet. I'll be spending some amount of time on neural networks and DNA image cryptography alone. Others, I'll just run through them quickly. Neural networks, this is by far one of the most interesting projects. You'll definitely want to spend a lot of time on this. I'm not sure how many of you saw the video that is posted about machine learning in the Tech Club signal processing group. So for those of you guys who didn't see, I'll just spend 2 minutes on neural networks. It's because it's a state-of-the-art algorithm and it's very interesting, and it is the first step in artificial intelligence. I have a very small presentation that has just 4 slides. So what is a neural network? Neural network was something that was formed based on our neurons. It's a mathematical model of our neurons. How did it come into existence? The first thing was some of the researchers, they wanted to mimic the functions of a brain. They actually wanted to create an artificial brain around the 1970s. Because our brain is able to process audio signals, video signals, it is able to feel touch, and there are so many things that our brain does. So they thought in order to create an artificial brain, they had to implement thousands of modules, one module for each activity. So they conducted some experiments. It's called as the neural rewiring experiments. This part of the brain is called as the auditory cortex, and it is this part of the brain that actually helps us listen to audio signals. This part of the brain processes the audio signals. So they connected the vein that comes from the auditory cortex and they connected it to the eye, and within a few days they realized that the auditory cortex actually learned to see. Similarly, this was another experiment that was conducted where the vein that comes from the somatosensory cortex, which is the part of the brain that actually helps us feel touch, was connected to the eye, and again the somatosensory cortex actually learned to see. From this, they concluded something. It is called as the one learning algorithm hypothesis. So, if any part of the brain tissue is actually able to process any signal, then they thought probably instead of having thousands of core modules in the brain, there is one learning algorithm that is present in the brain which automatically learns what it is supposed to do. So this is the origin of neural network and artificial intelligence. This is one reason why they say when you have some problem in the brain at childhood, it is actually possible to rectify it, especially if your brain is not able to process one particular signal, then it is actually rectifiable. These were some experiments that were conducted. Seeing with your tongue, this was one very interesting experiment, and active research is going on where they're trying to help blind people see through their tongue. This was a third eye that was implemented on a frog. So I'll stop the presentation with this and I'll get into the project. Yes, this is called as the digit classification using neural networks, where I train my network on several examples. These are the examples. I've given it almost 200 examples of 1 to 10 digits. So I'll run the code. Yeah, the number of examples in training data is 200. So I'm going to train my network on 200 examples. Is 25. Output is 10, 0 to 9. So it's 10 units. So my neural network is actually learning predicted output for the test data. This is my test data and it's giving the output as 2. I can give whatever number I want. I'll open paint and I'll probably write 3. If I write 3 and if I save it, and if I run that part of the code alone again, so this is the input that I gave and this is the output. Similarly, I have given only 200 training examples. If you want to make the system more robust, you can probably go for 1000 or 2000 examples so that it has a better accuracy. This is a neural network that was trained based on images of digits from 0 to 9. I'll have the same code and I'll train the network on some other data. For example, if I'm going to train the network on this data, if my input is just going to be decimal values from 0 to 9 and my output is going to be the rounded off value plus 1, I'll show you what I mean. It is the exact same code. I'm just going to change the input. I'll have the same number of units in the hidden layer. Output layer will have 11 units. So this is what I said. This is my input and this is my output. If my input is 1.6, my output is going to be 1.6 rounded off plus 1. So it's 1.6 rounded off, which is 2, plus 1 3. 3.9 rounded off is 4, plus 1 5, and it goes on. I've trained this network on 1000 examples. Once I press enter, it's going to train. This will take a couple of seconds. Yes, once it trains, I can give whatever number I want, and you can see that it'll produce a proper output. See, 1.3, when rounded off, it is 1, plus 1 is 2. Do I want to continue? Yes. I'll give probably 8.1. 8.1 rounded off is 8, plus 1 is 9. If I ask someone to write a code for this, then it is pretty simple. Maximum of 5 to 10 lines. Whatever number I give, I just round it off and then I add 1. We recognize this as a function, but I don't give this function to my neural network. My neural network automatically understands from the data. It looks at the data, then it automatically understands that probably the output is a round of value plus 1. I can train my network on almost anything, any kind of an image. Probably I can give it 1,000 images of ships, 1,000 images of bikes, 1,000 images of cars, and I can train the network on that. I can even train the network on audio signals. I can give one, two, three, all different audio signals, and then I can train the network. This is the first step in artificial intelligence. This is how they train algorithms, especially for chess and other things. Obviously, it is not this simple. It is just a basic step. As you can see, the code as such remains exactly the same. It is only the input and the output that varies. It is exactly the same that happens in the brain. It's only the input and the output that varies. So that is the first project on neural networks. I hope you found that interesting. For the second project, I think I'll go for something which is a lot of fun, color tracking. This I'll directly show you the demonstration of it. When I run the script, my webcam gets enabled. I'm sorry, it's in black and white. I'll just restore it. Okay, when I show something red, it is automatically going to track. It tracks red color, basically. Uh, that's my old phone. Yeah, so this is a pretty easy code actually, and it's a lot of fun to work with. And there are so many advancements that you can do for this code. For example, instead of red, you faces. That's what happens in your digital cameras. Okay, for my third project, I'll probably go for k-means image compression. This is also a very nice project. This is an image compression algorithm which is actually not used nowadays. Anyway, it'll give you a basic insight about k-means algorithm and image compression. I'll run the code. Enter the number of colors with which you want to represent the image. I'll probably give 16. It will take some time. But anyway, k-means clustering is actually a machine learning algorithm. This also comes under artificial intelligence. Yeah, this is my original image, and this is my image compressed with 16 colors. And as you can see, the original image occupies 48 MB and my compressed image occupies only 24. If I run the same script with 8 colors alone, it's going to be a little faster, but anyway, the output is pretty bad. Has only 8 colors. It is going to choose the 8 colors that occur the maximum in this image, and it is going to put them there. My original image size is 48 MB and compressed image size is 18 MB. This is also pretty easy, but you need some amount of background knowledge. For the fourth project, I'll show you guys DNA based image cryptography. This is one of the most advanced image cryptographic methods, and it was implemented based on this technical paper. I'll run the code. It'll take some time for the code to run. I'm sure most of you know what cryptography is. It is the art of sending a message in a secret way so that only the person whom you intend to reach the message to actually reach the message. So when it comes to an image cryptography, you transform the image from what it actually is into something else, and then you send it. For example, this is the original image. It's okay if you don't understand what an histogram is. It doesn't matter now. So this is the original image, and this is the encrypted image. So this is going to be the image that you're going to transmit to everyone, and there's something called as a secret key, which is just a few numbers, probably 3 or 4 numbers, that you give to a particular person, and with that 3 or 4 numbers from this encrypted image, he will be able to decrypt it and he'll be able to get back the original image. This cryptographic method has several advantages. One of the main advantages, or rather one of the main drawbacks of several other image cryptographic methods is, I told you there is something called as a secret key, right, which has 3 or 4 values. If my values are 1, 7, 8 and 3, and if there is some person who wants to read my message and he goes on a trial and error basis and he comes closer to the value, the closer he comes, the more of the image that he's going to recover. So if he's very close to the secret keys that I've actually encrypted the image with, then he will almost recover 75 to 80% of the image, which is actually bad. But one advantage in this cryptographic method is, even if you go wrong in choosing the secret key values at the 10 power minus 12th decimal place, even then you'll only get this image as the output. So unless you get the exact key, it is not possible for you to decrypt the image. One other advantage is there is something called as a differential attack that is being carried out in order to decrypt images. For example, consider the same original image. I'm going to encrypt it and I get this. And in order to find the algorithm, what I will do is I'll just change the first pixel value alone, and then and again encrypt it, and I'll see where that pixel goes. So I find the difference in the two encrypted images, and then I roughly find out what the algorithm is. Obviously, with not just this one pixel alone, I'll be doing the same change to several other pixels, and after some time I'll be able to find out. But this cryptographic method is resistant to differential attack, and it has numerous other advantages. One small issue about this is it is about 500 lines of code, but if you know the algorithm, it is very easy. It is not a tedious job to write this code. For the fifth project, I'll again show you a very simple image cryptography, not as complicated as the one before. Here, rather than image cryptography, it is actually the art of encoding a message within an image. I'll run the script, then you'll understand. So enter the message you want to encrypt. I'll probably give this as the message, a long paragraph. So this is the message which I'm going to encrypt. So this is my image, and this is the image encrypted with the message. That is, in this image I've actually encrypted this. So if you transmit this image, then someone else will be able to recover the message. So this is the decrypted message. So this is actually pretty cool, and the algorithm behind this is very simple, and it will maximum take a couple of hours for you to implement this. No one would actually guess that there is a message hidden behind this image. For the sixth project, I'll show you guys about audio signal processing. This is based on the video that was posted in Tech Club Signal Processing. In case you haven't seen, please do watch it. Once I run the script, it will ask me to record for my voice. Once I press Y, I need to record 10 seconds of my voice. Now I'm actually recording it. Once I record, I'll be able to add a lot of BGMs and some cool effects. I'll show you. This is my original voice being played back. To record 10 seconds of my voice. Now I'm actually recording it. Once I record, I'll be able to add a lot of BGMs and some cool effects. I'll show you. I'm sorry about the bad quality. Now the list of BGMs is being played. I'll probably add drums. Record 10 seconds of my voice. Now I'm actually recording it. Once I record, I'll be able to add a lot of BGMs and some cool effects. I'll show you. Next I'll add cello. Record 10 seconds of my voice. Now I'm actually recording it. Once I record, I'll be able to add a lot of cool effects. I'll show you. These are the list of effects that I can add: amplify, attenuate, fade in, fade out, stereo left, right, etc.
Stereo left and right, it'll be fun to listen to only if you have speakers. So I'll probably add fade in effect right now. Record 10 seconds of my voice. Now I'm actually recording it. Once I record it, it will add a lot of cool effects. I'll show you. So as you can see, the audio slowly fades in. Now once I press enter, it is going to play my processed audio of my voice. Now I'm actually recording it. Once I record it, will add a lot of cool effects. I'll show you. This is my original audio signal and this is my processed audio signal. So this is actually not a very difficult code, and maximum it will probably take 1 or 2 days for you to implement, and it's a lot of fun. The seventh and final project that I'll be showing you is on echo cancellation. This is something that is very important nowadays, especially when you use your cell phone on a loudspeaker mode. Consider this: the distance between the speaker and the microphone is in your cell phone is maximum of about 4 or 5 centimeters. So when you're using it on loudspeaker mode, whatever comes out of the speaker is definitely fed back into the mic, and this will be heard as echo at the other end unless it is cancelled. Echo cancellation is so advanced nowadays that you can comfortably use your phone on loudspeakers. This is a basic demonstration of it. So once I press enter, I need to record 5 seconds of my voice. So now I'm actually recording my voice and later I'll play it. Now if I press enter, it is going to play my original voice. 5 seconds of my voice. So now I'm actually recording my voice and later I'll. Now if I press enter, it is going to play my voice along with the echo. 5 seconds of my voice. So now I'm actually recording my voice and later I'll. Now if I press enter, it will cancel the echo and play it back. 5 seconds of my voice. So now I'm actually recording my voice and later I'll. Again, I'm sorry about the quality, but anyway, that will give you a rough idea about echo cancellation, and there are several algorithms that you can implement. LMS is a very basic algorithm. I hope you guys found these projects useful. These are not huge projects, but I'm sure it will definitely give you an idea about image processing, machine learning, and it will make you well aware of Matlab. If you're really interested in any of these projects, you can definitely take this to the next level. For example, if you're really interested in the neural networks project, then you can definitely try to implement a prototype of the automatic driving car that you saw in Tech Club Signal Processing. We'll also post about other projects that you can do. Thank you.